Hello, and today we're going to talk about the joints or arthrology. So the study of joints is called arthrology. So think of someone that has arthritis. So itis is inflammation of the arthro, which are joints. So joint inflammation is arthritis. So to study the joints, we call it arthrology. Okay, so what is a joint? It's an articulation. So when you put two things together, we call that an articulation. So a joint is where two bones come together or articulate. So if someone speaks well, you say they're articulate because they can join words together well. So that's an articulation. So this is a joint. So this is the humerus, this is the ulna, and so where they join is called the joint, and this particular one is the elbow. Okay, so where two or more bones meet, we call that an articulation or a joint. So these articulations, what do they do? What's their function? Their function is to allow the skeleton to move. It gives the skeleton mobility. They also hold the skeleton together. So where two bones come together at a joint, there's things there that hold those bones together. So it keeps your skeleton from falling apart. The things that hold the bones together, we have tendons and ligaments. Tendons connect muscle to bone, and ligaments connect bone to bone. So if you have a piece of connective tissue that's going from one bone to the other bone and holding that together, that's a ligament. If you have a muscle laying on top of a bone and it's connected to the bone, the piece of connective tissue that connects that bone and muscle together is called a tendon. A lot of people you'll hear use tendon and ligament interchangeably, and they're not. They're not the same thing. They're two different types of connections. So when we talk about joints, this is anatomy, so we love to classify and organize everything. So we're going to classify the joints, and one of the ways you can classify joints is on what they do. Remember, physiology, it's function. And so there's three functional types of joints. You have the synarthrosis, an amphiarthrosis, and a diarthrosis. So look at the beginnings of these words. So arthrosis is the joint, okay? The first part tells you what it does. Syn means together, so these do not move. They're immovable. Amphi, like an amphibian, can be in water and air, so kind of both ways. It means slightly movable. And dia is freely movable, like just think about diarrhea. I mean, you can freely movable bowels. So diarrhea is a freely movable joint. So the first part of the word tells you how much it can move. Syn means together, no movement. Amphi, a little movement. Dia, a lot of movement. So we can also classify the joints based on what they're made out of, so the structure or the material. And if there's a cavity present, if there's any kind of cavity between the bones. So we have fibrous joints, which are joined together with dense fibrous connective tissue. We have cartilaginous joints, which means they're joined by cartilage. And we have synovial joints, which means it's two bones separated by a cavity that has fluid in it. And these are the ones that pop and click. If you pop your knuckles, those are synovial joints. So three types of fibrous joints. We're going to kind of classify this more. So we have the three types of joints based on what they're made out of. So the first one was the fibrous joint, and there's three types of fibrous joints. So we have a syndesmosis, a suture, and a gomphosis. So an example of a syndesmosis would be where the tibia and the fibula come together. And a syndesmosis is two bones that are held together by ligaments, and these are amphiarthrotic. So if you can imagine standing, and you might want to do this, take a break, stop your video, stand up, raise one leg and try to balance on one leg. Now close your eyes. You'll kind of feel your feet wiggle just a little bit. You can almost feel your bones in your lower leg just sliding just a little bit. So it moves a little bit to help you with your balance. So it can move just a little bit. It's amphiarthrotic. The other kind of fibrous joints, you have a suture. And the sutures, hopefully you've covered some bone anatomy. This is what connects your skull bones together. And so we know after you've been born and those bones start to fuse, these do not move, so they are synarthrotic. So the sutures in your skull are synarthrotic fibrous joints. And then you have the third type of fibrous joint. It's called a gomphosis. And this is the joint, basically what holds your teeth in. Okay? So again, your teeth aren't supposed to move. So that's a synarthrotic joint where your teeth are held into the alveolar process of your mandible and your maxilla, called a gomphosis. You also have cartilaginous joints. So this is the type of joint that's formed using cartilage. So the types of cartilaginous joints are synchondrosis and a symphysis. So the first one we're going to talk about is the symphysis. And this is a fibrocartilaginous joint. You use fibrocartilage. And whenever you use fibrocartilage, that is a really tough joint. It's usually going to be strong, and a lot of times it's going to be found somewhere where you need cushioning and strength. So you have your pubic symphysis, which is a piece of fibrocartilage that holds your two hip bones together. So you want that to be strong because there's lots of weight pushing down on your pelvic cavity. And then you have your intervertebral discs, the discs that go between your vertebrae. Those are also fibrocartilage. And these are amphiarthrotic. They do move just a little bit. So imagine moving your spine, kind of rocking back and forth. Those vertebrae can just kind of move just a little bit. That joint is a little bit movable. And in females during labor, actually this fibrocartilage, this pubic symphysis, will spread just a little bit to open up the pelvic cavity to accommodate the head during childbirth. So a symphysis is a type of cartilaginous joint, and you find those between the hip bones and between the vertebrae. You also have a synchondrosis, and these are synarthrotic, so they don't move. And this is using hyaline cartilage. So remember, you have three types of cartilage. You have hyaline cartilage, fibrocartilage, and elastic cartilage. And so the hyaline cartilage is everywhere in your body except for your epiglottis and your ear. That's elastic cartilage. And fibrocartilage is between your hip bones, between your vertebrae, and the meniscus at your knee joint. So wherever you have this hyaline cartilage making a joint, we call that a synchondrosis. And so we have some examples where your ribs and clavicle connect to your sternum. And also the epiphyseal plate, which is a joint as these bones are growing. So in childhood and adolescence, as the bone is getting longer along the epiphyseal plate, that's a joint. And so we call that and it shouldn't move unless it's broken. So synarthrotic synchondrosis. Okay, and then you have synovial joints. So the last type of joint classified based on the material that you're connecting with is a synovial joint, and this is where you have a cavity that's filled with fluid. And so syn means together. Ovial, think about ova, which is the other word for egg. It literally means together with egg. And so if you could feel synovial fluid, which I have, I've done a cadaver dissection, it feels like egg white. And so that's why it's called a synovial joint. And these are freely movable. Like I said, these are the ones that when your bones move together, you hear the popping and the clicking. And so these are diarthrotic. And most of our joints are synovial joints. Okay, so anything that you can pop and click is a synovial joint between your fingers. I'm going to pop a few. And so we're going to talk about the 6 different types of synovial joints. So when you look at a synovial joint, kind of give you an idea what all's involved in making one. So here's a bone, and here is a bone, and they're connected by what's called an articular capsule. Okay, so basically you've got to have some kind of capsule that will hold that synovial fluid in. And so the capsule is made from the articular cartilage of this bone, the articular cartilage of that bone, and then a synovial membrane. Okay, and then you take a ligament, remember ligaments connect bone to bone, and you're going to basically cover or connect this bone to this bone and surround that synovial joint and hold it in place. Okay, and then they'll also have a fibrous capsule to kind of give strength to the whole joint. And so as these bones move over each other, they're held in place by the ligaments and this fibrous capsule, and they can smoothly glide. Okay, so that synovial fluid allows the bones to move against each other without crunching and not bone-to-bone contact. So the 6 types of synovial joints are hinge joints, plane joints, pivot joints, condyloid joints, saddle joints, and ball and socket joints. So we're going to talk about each one of these types of joints and give you an example of where you'd expect to find it and what the joint allows you to do. So the first one is the hinge joint. And these only move in one plane of motion. You may see the term uniaxial. They only move in one axis. And so think about the door. A door closes and opens, closes and opens. It only goes in one direction. So the movement that a hinge joint allows is flexion and extension. So think about your arm, your elbow. It flexes, extends, flexes, extends. It's just a hinge type of a movement. And so this would be your humerus and your ulna at your elbow joint is a hinge joint. Now, not the joint between your humerus and your radius. That's a different joint. Your elbow can do more than one movement, but the joint between your humerus and your ulna is a hinge joint. You also have it at your knee, your elbow, and your phalanges. So your fingers bend, straighten, flex, extend, flex, extend. I'm talking about the ones that like this these here, okay, flex, extend. Those are hinge joints. You have gliding joints or plane joints, and these allow for slight movement back and forth. And usually these are going to be the little short bones, like in your hand and your foot, that allow them to just kind of glide. So if you do this movement right here, so you can see these little movement joint between your metatarsals and your tarsals of your foot. If you move your toes, and then your metatarsals will glide just a little bit. Or again, when you're waving your hand, you get a little bit of gliding motion between your carpals and your metacarpals. Okay, now we have pivot joints, and pivot joints allow rotation around an axis. So the first one would be your C1 and C2, your top cervical vertebrae. And so the C1 fits on top of the dens of the C2 and allows you to make the no movement or rotate or pivot. Do you remember how to make the yes movement? Which joint that is? That's the occipital bone, the occipital condyles of the occipital bone articulating with the superior surface of the atlas. So this allows you to say yes. So the pivot, the rotation is C1 and C2, allowing you to say no. Another pivot joint is at the elbow, and it's where the radius articulates with the humerus. And so this point, so when you turn your hand down, you rotate your hand like this, that's actually your humerus and your radius. So this is your humerus and your ulna, this is your humerus and your radius. You have what are called condyloid or ellipsoid joints. And this is where you have kind of two oval surfaces, kind of one that's convex and one that's concave. And it allows all the angular motion. So if you think about the joint between your metacarpal and your phalanges, so your metacarpals and your phalanges, what you would call your knuckles, I would call them your metacarpophalangeal joints, allows you to do that. Okay, so it's an ellipsoid. You can make a cone. You have your saddle joint. And the saddle joint is found in basically two places. It's your thumb joint. And it's the carpometacarpal joint found at the base of the thumb. So between the carpal bone and the thumb metacarpal, the first metacarpal number 1, and allows you to twiddle your thumbs. That movement is called opposition. Okay, so we have opposable thumbs. That means we can touch all our other digits with our thumbs. So that's opposition. And that's unique to us, upper primates, having that saddle joint. We have a ball and socket joint. And so you're going to find your ball and socket joint. Basically, you have a ball that fits into a cup. And so you're going to see that at the shoulder and the hip. So the shoulder joint is a ball and socket joint. And where the femur articulates with the hip bone, the os coxa, you have the ball and socket joint there. These have the greatest range of motion. So of these two ball and socket joints, which one has the greatest range of motion? This one or this one, the shoulder or the hip? I can do a lot with my shoulder. So I'm going to say my shoulder, okay? So your shoulder has the greatest range of motion. You can do a whole lot more with your shoulder. And that's because it's not as confined. The femur literally sits inside this cup, and so it doesn't have as much flexibility or as much rotation or movement as the shoulder, because this is more of an open socket. You have more rotation and range of motion in the shoulder. All right, then one last thing I want to talk to you about synovial joints. Associated with synovial joints, you also have some structures that help reduce friction, and these are called bursa. And a bursa is a flattened fibrous sac that's lined with synovial membranes and has that synovial fluid. And it acts like a ball bearing. Basically, it protects the bone. Anywhere you have a ligament or a muscle or skin or tendon or bone that could rub together, you put a bursa there, your body puts a bursa there to help protect that and reduce friction. So I've got a picture. Here's the humerus, and here is the acromion of your scapula. And here's the ligament coming off of that bone. When your humerus moves, when you have rotation of this humerus, when the humerus is moving, you don't want the humerus to directly rub against that ligament. That would be painful, and it would cause friction, and it wouldn't be very effective. So the body inserts a bursa there, which is a fluid lined sac, to help give you more fluid movement. So if this becomes inflamed, you get something called bursitis. So bursitis is inflammation of the bursa. And so you'll see this sometimes people that do repetitive motion. Maybe they've got a job and they're doing the same thing over and over and over and over again, and that bursa thins out, and now you have the ligament lying right on the bone, and so you get pain. So bursitis can be painful. So sometimes it just requires rest to allow that bursa to heal. That's all we're going to talk about with joints today. So we'll do another video that talks about the joint movements and the different names that you use for how joints move, the different like flexion, extension, and things like that. That's for another video. So thank you for attention. Talk to you later. Bye.